Dear children, in session 3 of functions in Python, I will be discussing lambda functions and recursive functions. As you all know, there are 4 types of functions: user-defined functions, built-in functions, lambda functions, and recursive functions. So now we will see about lambda functions. The syntax to write a lambda function is, first you write the keyword lambda and then arguments followed by colon and then expression. Lambda, arguments, colon, expression. This is the syntax of lambda function. To use this lambda function, let us see an example. For this, you should take a name, preferably a function name or a variable name. So in the example, I am going to take square as the name. On the left hand side is equal to, square is equal to, and on the right hand side, I am going to define the lambda function according to the syntax. Lambda, I will take one argument a, colon, since this is to find the square of a. I am writing this lambda function to find the square of a. So the expression will be a into a squared, a into a. So to use this lambda function, you have to call, that is give function call by using the name which you have given in the left hand side, that is the name square. So in the print function, I am giving square of 7. So square is the name which you have taken in the left hand side of the definition of lambda function. Square of 7. So this 7 is taken as the argument, that is the value for a, and square of 7 will calculate 7 squared, which is because of the expression a squared, and then you will get the output as 49 because the function call is within a print function. Now I will show you some examples of how to use lambda function in the Python IDLE. The syntax of lambda function is lambda space arguments colon expression. So let me show you the example which I discussed earlier. That is a lambda function to find the square of a number. So on the left hand side, I take a function named square is equal to lambda, the keyword lambda, L-A-M-B-D-A, lambda space. Now I have to give the argument. I take a as the argument and I want to find the square of a. So how to write the expression for square of a? It should be a into a. This is one way, or you can use the exponent operator to the power of operator and you can write the same expression a into a as a to the power of 2. Both are same. A into a is same as a into 2. This is a square. So I will go with the a into a. Now to use this lambda function, let me take a print statement. Within the print, I should give the name in the left hand side, that is square of, and within parenthesis, now I should give the actual argument for which I want to find the square. So suppose I want to find the square of 7. So this is the way you use the lambda function. So look at the output. Square of 7 is 49. So how you are getting 49? Because the value of a is 7 and the expression is calculated 7 into 7. A into a is calculated, which is 49. Okay, I will show you another example. Suppose I want to find the sum of squares using lambda function. So sum of squares of two numbers a and b. So sum of squares is equal to lambda a comma b. So I want to find the expression a square plus b squared. So a into a plus b into b. A square plus b square. So when I give two values to this lambda function, it will calculate a square plus b square. So print. So here when you are using the lambda function, you should give the same spelling, sum of squares, and here in the arguments I should now give two values for the two arguments a and b. Suppose I give 3 for the value of a as the value of a, comma, and 4 to be the value of b. So this function, lambda function sum of squares, will calculate 3 squared plus 4 squared, because a is 3 and b is 4. So 3 squared, 3 into 3, which is 9, 4 into 4, 16. So 9 plus 16, 25. So check out the answer. You are getting 25. So this is how you write lambda functions. Now compare user-defined function with the lambda function. User-defined function begins with the keyword def. Lambda function begins with keyword lambda. And you can see that user-defined function has an action block, that is body of the function. Whereas lambda function is very small. It is made of only one statement. When and where lambda functions are used? Lambda functions are mostly used for creating small one-time anonymous functions. Lambda functions are mainly used in combination with functions like filter, map, and reduce. Next, I will discuss recursive functions. What are recursive functions? Functions that call themselves are called recursive functions. Let us see the syntax of a recursive function. First you write the keyword def and then the function name, and within parentheses you place the parameters, and after the parenthesis there is a colon, and in the body of the function there is a condition. So condition always comes with an if statement. If condition colon, and if the condition is true, an action is given. Here I have given as return expression 1. And if the condition is false, that is it is the else part, else colon, there is another action which takes place, return expression 2. The condition inside this recursive function is called as the base condition. A base condition is a must in every recursive function. And the action that takes place when the condition is true is called as the base case. And the action which takes place when the condition is false is called as the recursive step. Okay, let us take the example of factorial of a number and analyze it with the recursive function. So here you can see this program calculates factorial of a number by using a user-defined function. Now I'm going to write the same program with a recursive function by applying this syntax. Okay, how is n factorial calculated in user-defined function? N factorial is equal to 1 into 2 into 3 into etc. into n. That is, fact of n is equal to 1 into 2 into 3 into etc. into n. That is, that function factorial calculates the product of these natural numbers up to n. If I apply this for 5 factorial, that is 5 factorial is equal to 1 into 2 into 3 into 4 into 5. That is, fact of 5, that is when I call the function with input 5, it actually calculates 1 into 2 into 3 into 4 into 5. This is what is happening in the user-defined function. If I want to change this problem into a recursive function, that is, I want to calculate factorial of a number recursively. Let us see that. So 5 factorial can also be written as 5 into 4 into 3 into 2 into 1. So in this, 4 into 3 into 2 into 1 is nothing but 4 factorial. So I can write this step as 5 factorial is equal to 5 into 4 factorial, which means fact of 5, that is, if you want to calculate the factorial of 5 is equal to, you have to calculate 5 into factorial of 4, fact of 4. So fact of 5 is equal to 5 into fact of 4. So if I apply this for a number n factorial is equal to n into n minus 1 factorial. That is, if you want to find the factorial of a number n, then you should find the product of n and the factorial of 1 less than n. So fact of n will be n into fact of n minus 1. So in this step you can see that the function fact is calling itself in the right hand side, but with reduced input. In the left hand side it is n, the input is n, but in the right hand side the same function fact is called with reduced input n minus 1. So this is the trick that needs to be used in a recursive function. I will show the actions in a recursive function step by step. Here 5 factorial is equal to 5 into 4 factorial. So to find 5 factorial, you have to first calculate 4 factorial. Then only you can do the product 5 into 4 factorial. So you have to calculate 4 factorial. What is 4 factorial? It is 4 into 3 factorial. So to calculate 4 factorial, you should first calculate 3 factorial. So you go on to calculate 3 factorial, which is 3 into 2 factorial. And again, now you have to calculate 2 factorial, which is 2 into 1 factorial. And 1 factorial is equal to 1 into 0 factorial. You cannot proceed further because now you have touched the base case. So 0 factorial is equal to 1. That is the base case. So you have to substitute 0 factorial is equal to 1 in the last step. So 1 into 1, which is 1. So now you have got the result for 1 factorial, which is 1. And this value must be substituted in the previous step. 2 into 1 can be now calculated as 2. And this result of 2 factorial is substituted in the previous step. So 3 into 2 is 6, which is the value of 3 factorial. Now when you get the value of 3 factorial, now you can substitute it in the previous step to do 4 into 6, which is 24. Now 4 factorial is 24, which can be now substituted in the first step to get the result of 5 factorial as 120. So in the recursive function, there are two important steps. One is the recursive step, and at the last is the base case. This recursive step has to be repeated again and again until you hit the base case. So like this, you go on repeating the recursive step, and when you touch the base case, once again you have to come backward. So you have spiraled down. When you touch the base case, you have to come up. So 1 factorial should be substituted in the previous step. 2 factorial answer should be substituted in the step before it. 3 factorial to be substituted in the ahead step, and so on. Finally, you reach the final step, or you come back to the starting. So this is how recursion works. So here, when you are spiraling down, when you are doing the recursive step again and again, there will be a number of times you are doing this, repeating this step. That is called as the recursion depth. So how many times you are repeating the recursive step, that is called as the recursion depth. So here, which is the recursive step? N factorial is equal to n into n minus 1 factorial. In this, n into n minus 1 factorial, n minus 1 factorial is nothing but the function called fact of n minus 1. So the recursive step is n into fact of n minus 1. And which is the base case? 1 into fact of 0. That is 1 into 0 factorial. 0 factorial is nothing but it's a function called fact of 0. So fact of 0 is 1. That is the base case. So now we are ready to write the recursive function following the syntax which I have already discussed. So using this syntax for recursive function, let us fill up this syntax. So first you write def, and then the function name fact, and within parentheses n is the parameter, colon, if condition. So if the condition should be n is equal to 0, colon, n is equal to 0. That is, n may be any number, but it will go on reducing in every recursive step, and finally it will touch the base value, base case, that is n is 0. And if n is 0, you want to find 0 factorial, which is nothing but 1. So recall the base case is 1. So you have to return 1, which is the base case. Else, that is if n has not touched 0, then you have to do the recursive step. What is the recursive step? N into fact of n minus 1. So here you fill the recursive step, return n into fact of n minus 1. Now we have formed the recursive function. Now we can substitute this one in the place of the user-defined function of our factorial program. So here you take this recursive function and place it in the place of the user-defined function, Now you have got the recursive function to calculate factorial of a number. So let us see the same example in the Python IDLE. So we will run the program to find the factorial of a number using a recursive function. So here is the program. So in this recursive function, you can see that the name of the function is fact. Here is the name of the function, def fact of n. And you can see in the body of the function, the same function fact is called again within its body with reduced input n-1, fact of n-1. So here this fact function is calling itself within its body. That is the meaning of recursion. A function calls itself. So let us run this and see. If I give input 5 for n, factorial of 5 is 120. Okay, so for which, up to which number this program, this recursive function can calculate the factorial? Can it calculate for 100 factorial? So if n value is 100, factorial of 100 is such a long number because it has multiplied now 100 into 99 into 98 into like that. Okay, 100, it is calculating for 100. Okay, will it calculate for 1000? 1000 factorial. It is throwing an error. Recursion error. Maximum recursion depth exceeded in comparison. What is recursion depth? I showed you already. So during the recursive step, when the recursive function, it is spiraling inside to reach the base case, the number of times the recursive step is happening is called as a recursion depth. So there is a maximum limit for it. So sometimes when the recursion depth, the limit crosses the recursion depth, default recursion depth, it will throw error like this. Okay, so 1000 factorial is not possible. So up to for which number the recursive function can work? Let us try for 990. Okay, it is calculating 990. So it's a very large number. The factorial of 990 is something big. Okay, it's calculating 990, but it is not calculating for 1000. For 992, let us try 992. Also, it is working. 993. If I give the input as 993, it's just throwing error. So this function, recursive function, it can take a recursion depth up to 992. Okay. Now, but in the textbook, they are saying that the recursion depth, the default recursion depth is 1000 calls. The recursive calls, function calls is 1000. But it is not calculating 1000 factorial. It is calculating up to 992 for 992 factorial. Suppose I want to find the factorial of 1000 or factorial of 2000. So you know it is throwing error. It is not possible. But there is a way to set the recursion limit to a higher limit, more than 1000. So for that you have to add two steps here. First you have to import the module called sys, import sys, and then you have to give sys dot set recursion limit. So what is the use of set recursion limit? You can advance the limit which is 1000, you can advance to a higher limit. So suppose I say 2000. Set recursion limit 2000. And now when I run this program and I want to find the factorial of 1000, I give input as 1000, it is able to calculate. So if you want to find factorial of 2000, you have set the recursion limit up to 2000. If I give the input as 2000, it is not able to, because the maximum recursion depth has exceeded. So you have to increase the recursion limit to 3000. Now you can calculate factorial of 2000. So it's such a big number, it is not able to show. So it has squeezed the text. It is saying double click to expand. Okay, look at the output. The factorial of 2000 is, oh, it's such a large number. This whole thing is actually one number with so many digits. So I think all of you have understood recursive functions. Thanks for watching.